Hi, so in this video we're going to start working with integrals of secant and tangent and combinations of them. And we're going to start with the most basic one. In fact, we're going to start with tangent of x. Tangent of x, we do not have a simple function whose derivative is tangent, so we do not have a simple antiderivative. But thinking about this for a bit, we can realize that we can remember that tangent is just sine of x over cosine x. And then we can see this like, oh, remember that the derivative of the sine function is the cosine function, and the derivative of the cosine function is a negative sine. So if we do here a little u substitution, if we make, say, u to be the cosine x, then its derivative is negative sine of x. So I can write this like negative sine x. Sorry, I don't want the negative. So if I solve for the sine x dx part, I get negative du. So here, these two guys together become this, right? So replacing sine x dx for negative du, I end up having, this is negative du, and I have the negative, I took the negative outside, and I have over u. So this is a simple natural log, right? So if I integrate this, I can do it now, and it becomes the negative natural log of the absolute value of u plus a constant. Now I should not leave it like that. I have to go back to my original function, which was cosine. So this becomes a negative natural log of the absolute value of cosine x. And I can leave it like that. That's my final answer, but you can also use the properties of logs to bring this negative to the negative 1 power over here. So it really becomes natural log of cosine to the negative 1. So I'm right here 1 over cosine x. But 1 over cosine x is the secant. So there you go. This is the natural log of the absolute value of the secant of x plus a constant. And that's my final answer. Okay? So we have the integral of the tangent. It's a little bit of work to get that done, but it's not that complicated. Now to find the antiderivative of the secant, this is a little bit more trickier. What we need to do is remember first that the secant being 1 over cosine is not going to work here because I don't have its derivative, so you use it to make use of the u substitution like we did in the past. I don't have a sine function to do it. So we're going to recall that the derivative of the secant is secant tangent. So trying to use that, and the derivative of the tangent is secant squared. After we think about this for a few minutes, there's a trick to do this, and I'm going to do, I have a secant x, and the trick is to realize that if you multiply top and bottom by the quantity secant x plus tangent x, you're going to have the magic to work out and complete everything you need to do this, because the first term is to be secant squared, which was the derivative of tangent. The second one is going to be secant tangent, which is the derivative of secant. And I have exactly that in my denominator. So let me write it down. This became the integral of secant squared of x plus secant x tangent x. In the bottom I have secant x plus tangent x. And what I'm saying now is that if you make a u substitution where u is secant x plus tangent x, then precisely the derivative of that would be, the derivative of secant is secant tangent, and derivative of tangent is secant squared, which is exactly what I have in this numerator. Okay, so I have 1 over u du. Again, I don't need a sign here. I really just have 1 over the u part of the du part. So the antiderivative of this becomes the natural log of the absolute value of u. And now I just go back and plug it in. My u was secant x plus tangent x. Okay, so there's a trick for this one. It was not as simple as the other one, but we worked it out. Now, what do we do in more general cases? So we have these two things. We know that the derivative of tangent is secant squared. That means that the integral of secant squared would be the tangent plus a constant. And the other derivative rule we know is that the derivative of secant is secant tangent, which means that the integral of secant tangent would be secant x plus c. But in more complicated situations, we're going to have to use this trig identity that if you don't remember this one, it's not a big deal. Everybody should remember this one, sine squared plus cosine squared equals 1. And this comes from that one when you divide every term here by cosine squared. If I divide this one by cosine squared, this one by cosine squared, that one by cosine squared of x, this becomes the tangent squared. This is a 1, and this is your secant squared. So this identity is not a new one to use in your memory bank. It's the one you already have. This one, just divide each term by cosine. So how do we use it? So I'll do one more example in this video, and then make other videos with more complicated examples. So I'm going to start with tangent cubed. So how would we do tangent cubed? Well, I'm going to use the fact, I'm going to try to use these identities and these, try somehow to use that the derivative of tangent is secant squared, derivative of secant is secant tangent. Now how I'm going to make it work here? Well, it's going to be a little bit complicated because I have a tangent to the third power. So one way we can do this is, let's split this up like tangent squared times tangent. Why am I doing that? Because on this first term, I'm going to use my identity to convert it to secant squared minus 1. Okay, I'm going to use this identity right here. Solve for tangent squared. So I get secant squared minus 1 times the tangent x dx. So what I have here is, if I distribute, I have secant squared of x minus tangent x, which works out because I can do the secant squared. This is the secant squared of x is the derivative of tangent, and then I have the integral of tangent, which we already did in the past. So this becomes two integrals, the integral of secant squared and the integral of tangent. So this one we did at the beginning of the video, and this is just the derivative of tangent. So this is tangent x. Oops, I did something wrong. Yes, sorry, I read something wrong here. I forgot my tangent x. I could edit my video, but I'm going to leave it like that. So yeah, we do mistakes sometimes. So this becomes secant squared x. I forgot my tangent, right? Minus tangent x. That's what I have. Yeah, it was not as simple. So I have a secant squared tangent minus tangent x. The tangent x is the one I can do simple. The secant squared x, it's a little bit tricky, but it's not hard. Remember that the derivative of secant is secant tangent. So if you see this one as secant x, times secant x tangent x. So what I'm doing is splitting this one up into terms like that. Why am I doing that? Because this is the derivative of this. So I have u and its derivative, u du. Okay? So if I split this one like two integrals, then I have like this. Okay. And now all I have is u du, which is u squared over 2. I'm going to skip the part where I write that down. This would be 1/2 of secant squared. Right? And then over here, the derivative tangent is the one I did at the beginning, which was the natural log of the absolute value of secant x. So there you go. So this is my answer. And for any of these, we can check by taking derivatives and see that we actually get our answer. Okay, I'll make another videos with more complicated examples.